Hey! Meet Jonathan Jeff Mercado, a piggery owner from Barangay Banabo West, San Pascual, Batangas. For Jeff, his piggery is more than a source of income. It is also a difficult reality. See, Jeff deals with persistent other problems beyond the farm and into nearby homes. He struggles with high energy consumption, knowing that every pig cleanup, every pig food, and everything that needs the piggery running adds to a bill that keeps inflating. He works through repetitive and exhausting tasks, managing the waste, monitoring pig health, and responding quickly when one animal shows signs of stress or illness. Because in pig farming, a sick pig can become a loss, and not too far to become a disaster.
Jeff's experience is not unique. It reflects the everyday challenges of piggery owners across Banaba West and the concerns of the residents who live beside them. The odor, the waste, the health risks, the strain on resources. These are problems felt on both sides of the fence. And at the center of it all is one overlooked element: pig waste. Produced every day, difficult to manage, and rarely used for anything beyond disposal. But what if? What if that waste could do more? What if the same slurry causing odor, disease risk, and energy restraint could actually become a renewable source of energy for the community? And maybe, what if we attach this to a device that can monitor the health of swines?
Meet FineSwine!
So, what does it do? Well, first of all, the FineSwine system is divided into two components. The first component is the microbial fuel cell powered by the pig slurry microbial substrate. Next is the second component, the sensor. It is an early respiratory health sensor for swine. So let's imagine this prototype in a Minecraft world setting. So let's look at the power source. This is the microbial fuel cell unit. For the housing, we utilize PVC tubing. We selected this material because it provides structural stability, is corrosion resistant, and naturally floats, which is essential when the device is submerged in the pig slurry. The energy generation happens here at the electrodes. Instead of expensive platinum, we use stainless steel mesh coated with activated carbon. Naturally occurring bacteria in the way colonize this anode. As they break down the organic matter, they release electrons which travel to the cathode. The cathode is air-breathing, meaning it uses oxygen from the air to complete the circuit. To manage this biological energy, we integrated a 10 microfarad capacitor. So maybe think of this as a storage bucket. It collects the trickling electrons from the bacteria until it holds a stable charge. So literature confirmed that this capacitor operates within 15% accuracy margin, ensuring we can capture enough energy to pulse power to the sensors. So while the MFC generates the power, this device provides the intelligence. This is the early swine respiratory health sensor. So first, the housing is a repurposed PET bottle. It is cost-effective, waterproof solution for farm environments, and we drilled specific holes here to allow sound to reach the microphone while protecting the electronics. And to add, we add a special protection coating so that it would remain durable, especially in the piggery environment. Let's simulate the detection process. Inside is the Arduino Nano 33BLE. It uses a built-in microphone and tiny ML to process sound directly on the device. For the detection, the system is trained to recognize the specific sound pattern of a pig's cough. So, we can insert about 1,000 plus sound files so that it can maintain an accuracy of 99% within the range of 2 to 3 meters. Once a cough is detected, how does the farmer know? So, we use a dual-path communication system. First is the ESP8266 module, where it sends data via LP1 to our Internet of Things dashboard for long-term health tracking. So it can be used for an instant SMS transmission to the owner and caretaker whenever the sensor detected abnormal coughing of a pig. Second, for urgent alerts, we use the BRK WSO1 Sigfox breakout board. This uses LP1 technology to transmit signals even without Wi-Fi, so it serves as a personal cloud and private server that would allow to create charts and allow other web devices and web components to process the data. So, it transmits signals even without Wi-Fi and sends the alert to the cloud, which triggers an immediate SMS notification to the farmer's phone. To summarize this simulation, the MFC treats the waste and generates the necessary electrons. And those electrons power the sensor, which detects illness before it spreads. This is FineSwine, turning waste into wellness.
First, we learned that pig slurry can theoretically function as an organic energy source. Scientific literature shows that natural bacteria found in pig waste are capable of generating electricity through MFCs. This means that the waste causing so much odor and inconvenience could instead become a renewable resource for the community.
Second, we asked, can this be done affordably? And their theoretical design suggests yes. Using accessible materials like PVC housing and activated carbon-coated mesh, a system like FineSwine could be achievable even for small farm areas in Banaba West. The catch is that a single MFC wouldn't generate enough energy. Thus, a system would need to be modular, stacked together to meet practical needs. But the pathway is there.
Third, we look beyond just energy. We ask, how can this help farmers and residents at the same time? By pairing MFC-based energy recovery with edge computing respiratory monitoring, FineSwine proposes a system that not only repurposes waste, but also supports better pig health, catching early signs of respiratory issues before they spread.